All right, in this video lesson, what we're going to be talking about in section 1.9 is going to be how to prove triangles similar using a new similarity method, which is SAS, which stands for side angle side. So, side angle side similarity, SAS, is where you have two sides of one triangle that are proportional to two sides of another triangle, and the included angles are congruent. And if you have that, then the triangles must be similar. In other words, in our triangles on the right here, we already know that angle X is congruent to angle M. And so what we would want to show is that our side, such as side XY, is proportional to side MN, so this side being proportional to this side, and the other included side, so XZ, would have to be proportional to side MP. Notice that we're not talking about the third side, so the side that's across from the angle is not going to be a side that we can use for side angle side. It has to be the two sides that are around your angle, which is why it's written as SAS. So let's take a look at some examples where we're trying to show two triangles similar by side angle side. So our first triangle that we're going to look at, we've got triangle SER and triangle FEG. By vertical angles, we can say that angle E is congruent to itself in each of these two triangles. So really all we have to check is whether our sides are proportional or not. So picking our smaller side of each of those two triangles, that would mean that 6/24 would have to be proportional to picking the other sides, 12/48. So typing those into a calculator, 6/24 is 0.25, and 12/48 is also 0.25. So these triangles are in fact similar. What we're going to say then is that triangle SER is similar to triangle GEF, and that's by side angle side similarity. Okay, let's take a look at the next one. So our next one, we're going to start kind of the same way. We've got these two vertical angles which are congruent. However, notice that this is not set up as side angle side. In this case, we have side, side, and then angle, and also side, side, and then angle. Instead of having side angle side, what we really needed to know what this side length was right here and right here. And so because we don't know what those two sides are, we're not going to be able to determine if these are similar by side angle side. And so we're actually not going to be able to say that they are similar. All right, let's take a look at another example here. So in this next example, important to notice that we've got these parallel lines because of the arrows right here, which means that we're going to be able to say that some angles are congruent to each other, namely that M is going to be congruent to P. So there's our angle that we needed to have congruent. Now we just need to check our sides. So let's start with our short side of the two triangles, which would be that 22 would need to be proportional with 36, and that the next side, 33, would have to be proportional with 54. All right, so typing those into a calculator, 22 divided by 36 is 0.61, and 33 divided by 54 is also going to be 0.61. So we do in fact have two triangles that are going to be similar. We're going to say that triangle CMP is similar to triangle RPQ, and that's going to be by side angle side similarity. All right, let's take a look at our next example here. So we've got triangle EFG and triangle HJK. We already know that we've got one angle that's congruent, which is that G is congruent to H. So let's compare our sides. Starting with our shorter side, we'd have that 45 would have to be congruent to 31.5. I underlined the wrong number first. But yeah, 31.5. And that 50 would have to be congruent to 35. Or not congruent, but proportional to 35. All right, so let's type those into a calculator. 45 divided by 31.5 is 1.43. And 50 divided by 35 is 1.43. So again, because those are equal, you can now say the triangle EFG is similar to triangle, let's see, we would want to start with J and then H, or JK and then H. So make sure that you're going in the right order with those sides. And that's again by side angle side similarity. All right. For our last two, we're going to look at the examples where you've got an included triangle. So in each of these cases, to set it up, notice that this angle of W is going to be similar to, or congruent to itself in both the smaller and larger triangle. As is triangle on the next example, L is going to be congruent to itself for both triangles. So we really just have to check the sides. So on our first one, if we start with the short side is 14, compared with, make sure to include the whole side, which is 42. So 14 over 42. We want to be proportional to 15 is the longer side of the smaller triangle. But again, you want to compare that to the larger side of the entire big triangle. So 30 plus 15 is 45. And now we can compare those. 14 divided by 42, when you type that into a calculator, is 0.3. And 15 over 45 is also 0.3. So we can in fact say that triangle QWR, which would be the smaller triangle, is similar to triangle SWZ, and that's by side angle side similarity. All right, let's now take a look at our other triangle. So we'll start by looking at our shorter side of the smaller triangle. So that would be that 27 needs to be proportional with, looking at the entire side length, is 27 plus 7, which is 34. And so that needs to be equal to the proportion that is 30 over, looking at the entire length, 30 plus 9 is 39. So let's type those into a calculator, see if they are similar. 27 divided by 34 is 0.79. 30 divided by 39 is 0.77. And so in this case, because they are not proportional, then our triangles are not similar. All right. So we're going to work through a few more examples here. These next 4 examples are just asking if the triangles are similar. We're going to have to decide, though, if that's going to be by angle, angle. So angle, 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 where it's 3 A's is the same as where it's just 2 A's. Also, we could have by side, side, side. So one way, second way, and the third way that we've been talking about today is by side, angle, side. If so, we're going to write a similarity statement. Okay. So we really want to kind of look at what we are given before we try to prove that they are similar. For example, in our first 2 triangles, we're given a side, an angle, and a side, an angle, and a side. So if these are going to be proportional, they're going to have to be by side, angle, side. We've already got that the 2 angles are congruent, so we're good there. So let's see if 3 and 9, which are the 2 shorter sides, are proportional to our two longer sides, which are 5 and 15. Which, typing those into a calculator, 3 divided by 9 is 0.3. 5 divided by 15 is 0.3. And so yes, these are proportional. So we can say that triangle EFG is similar to triangle RTS. And that's by side angle side similarity. All right. For our next example, again, let's decide what type of similarity we're going to try to show. We're given side, side, side on our first triangle and side, side, side on our second triangle. So if these are going to be proportional, similar, we have to make sure that all the sides are proportional. So our shortest side is 22 over the other shortest side is 16, which 22 divided by 16 is 1.375. Our next shortest side is 28, and our next shortest side over here is 20. So if you take 28 divided by 20 is actually 1.4. And so right away, because those two are not equal to each other, and remember, you do not want to round when you're checking for proportional. And so in this case, because they are not equal to each other, we can right away say that these two triangles are not similar. Okay. Our next triangle, and actually two triangles, are going to be using some information about parallel lines. Obviously, we know that angle H is going to be congruent to itself for both of the two triangles, the small one and the large one. So what we want to do is, using those parallel lines, talk about corresponding angles. The angle B and angle G are going to be congruent, and then angle C and angle I are also going to be congruent, which would tell us that these two are actually going to be congruent by angle. So we've got the triangle HBC is going to be similar triangle HGI, and that's going to be by angle, or if you wanted to write angle, similarity you could. All right. For our last triangle, we're looking at kind of what we've been given, which is side, 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 and side, side, side. And so we're going to look to prove that these are similar by side, side, side similarity. All right, so starting with our smaller triangle, which is triangle PXY, our shortest side is 12, needs to be proportional to 16, which 12 divided by 16 is 0.75. Our next shortest of triangle XPY is YP, which was 15. And for the larger triangle, make sure you look at the entire side from R to P, which 5 plus 15 is 20. And 15 divided by 20 is in fact 0.75. So far so good. One last side to check, which is the side XP, which is 18, over, remember to look at the entire side from Q to P. 6 plus 18 is 24. And so 18 divided by 24 actually ends up being equal to 0.75. So we can say that all of these proportions are equal to each other, so all of our sides are proportionate. So we can go ahead and say that triangle XPY is similar to triangle QPR, and that's by side, side, side similarity. All right, let's look and see how we can use these properties in some real world problems. So determine the height of a very tall pine tree. You obviously probably can't just bust out a tape measure and walk to the top of the tree and drop the tape measure down to your friend and see how tall it is. So instead what you do is you place a mirror on the ground and stand where you can see the top of the tree. How tall then is the tree? Well, here's what we know is that the angles made by this mirror, which is kind of hard to see, let me zoom in, are actually similar angles. And so what we're going to be able to do is we're going to be able to use proportions to solve for the height of the tree. And so to do that, what we can say is that this distance that you are from the mirror, which is 2, and 6 have to be proportional to the distance between the mirror and the tree, which you measured to be 24. And the only thing we have left to find is the height of the tree, which I'm just going to call h. So now we've got a proportion set up where we can solve for h by cross multiplying. 2 multiplied by h is 2h, and 6 multiplied by 24 is 144. So now to get h by itself, we're going to divide each side by 2, and we're going to find out that h is equal to 144 divided by 2, which is 72, and then make sure to include the label. Everything was in terms of feet, so the height of our tree, it looks like, is 72 feet tall. Okay, let's look at another example. So you're standing 15 meters from building A. I'm going to go ahead and label that since it wasn't already for us. So you are 15 meters from building A. Building A and building B are 35 meters apart. So this distance in between here is 35 meters. If building A is 90 meters tall, so you've got 90 meters right here as your height, what is the height of building B? And again, I'm going to call that H. Go ahead and also draw in kind of this side of the triangle so we can see that it is in fact a triangle. And we've got this same angle between A and B. Okay, so let's set up our proportions here to those. And so in order to solve, what we've got is that 15, which is the shorter length here, has to be proportional to 90. And then the longer length, which makes sure to add those two together, 15 plus 35 is 50, has to be proportional to the height of that second building. So now we can solve by cross multiplying. 15 multiplied by h is 15h. 90 multiplied by 50 is 4,500. And then to get h by itself, one last step to go. We divide each side by 15. And we get h is equal to 300. In this case, our labels were meters, so 300 meters. So our height of building B is 300 meters tall. All right, that's all we've got for today. In the next video, we'll be talking about mid-segment of triangles. Until then, have a good rest of your day.